This is Haskell lab number 1. And the idea that I have for the labs is rather than just talking about the language, this is a time when we will go into some code. In this case, it's code that I've written, a game called Dodgy Dice. The next labs are going to be probably 2 labs to cover it, a Lisp interpreter that I have been writing, and currently have to debug the macro system, which is horribly broken. Everything else in it works. So the idea is to get into real code and just all of the things that come up, all of the functions that I use or tricks that I use, I explain them. That way you get a sense of what real Haskell code looks like. So first of all, are there any questions that people want to ask? It doesn't have to be related to lab1.hs. Yeah, what's up?
What does, when you compile like an HS file, does it compile like straight to bytecode?
It compiles down to native code if you wanted to.
Native.
Yeah. Yeah. Now GHCI is an interpreter, and that's going to be slower. So your performance in GHCI is not going to be representative of what you would get in compiled code, especially if you use optimizations.
Are we going to get to those optimizations?
Well, when I say when you use optimizations, I'm talking about compiler optimizations, -02, which you'll see in a project.
So you meant some pound sayings in the code. You showed the other day some stuff that looked pretty weird.
Oh yeah, that stuff. Those are unboxed types. We might get to them later in the course. The first 6-7 lectures are sort of mapped out, basically getting us to monads. And then after that, it opens up a lot. There's a lot that we can look at, and unboxed types are certainly one thing that we could explore.
So all types are inherently boxed in Haskell?
The ones that we've seen so far are boxed. The capability for unboxed types is there. And when you're writing very high performance code, you'll use unboxed types. For the work that we're doing, it doesn't matter. Anything else? Great. So Dodgy Dice is the game that is playable at the command line if you have the GitHub repository installed. It's a 1-player game with 2 6-sided dice. You have 4 lives, and you start with a score of 0. Kind of makes sense to start with 0. And you play it in rounds. And it's sort of a press your luck dynamic where you roll the dice, and if you get a 1, then you lose a life and you don't score any points. And if you roll snake eyes, that's 2 lives. And you can choose to stop rolling, and then you score the points for everything that you've rolled. The rounds get a little harder as the game progresses. In the first 3 rounds, you have to make at least 1 roll before you can stop. So it's just 1 forced roll. Rounds 4 to 6, it's 2 rolls. 7 to 9, it's 3, and so on. And normal rolls that don't have 1s are worth the combined total on the dice. And if it's doubles, then you double it again. So 5-4 is worth 9 points. Double 6s is worth 24 points. So here's an example play. You know, we get a 5-4, that's 9 points. Double 3s, that's 12. 4-6, that's 10. 31 points, that's a pretty good round. So we stop. Second round, we do 3-2, it's 5 points. 1-6, well, we rolled 1, so the round ends and we lose a life. Third round, we roll double 5s, that's 20 points. At that point, you probably want to stop and take your 20 rather than keep pressing your luck. Fourth round, double 6s, 24 points, and then snake eyes. So you're kind of screwed. And you couldn't have quit after the double 6s because in round 4, the first 2 rolls are forced. So in round 5, 6-5 and 3-2, we stop pressing our luck, collect our 16. Round 6, well, we just kind of get screwed there. It's not a very strategic game, a lot of luck involved, a little bit of strategy, but it's about the code rather than the the game itself. So if you haven't played it, here's how you can do it now. Git clone that URL, cd into the directory, cab will configure, cab will run, and there you go. It'll actually take a while because it depends on a few libraries that would take a while to install. But because I think you also have to, I think there's actually an error here. Let me fix this. You got to do install. So let me just fix that. But to demo a game of this,
I just ran GHC and then the file name and then executed the file, the executable and then it generated. I didn't actually do anything with Cabal.
and did that work? That works, yeah. Yeah, that will work. I'll go over that.
I wasn't sure if I was like missing something because I did that.
No, you're not. That's one way to do it. With large projects, though, you don't want to be manually linking and compiling.
Yeah, for sure.
So let's play Dodgy Dice. And I played this game enough, so I'm going to let the class go. So the first roll is forced. 7 points. Are we going to roll again?
Yeah, let's do it.
Yeah.
Oh, you lost us a life. Sorry.
Nice one.
3 lives, no
I'll take
points.
Riskus.
Risk. Let's
Forced roll.
I can't tell.
We got 8 points.
go again.
Uh, and you lost us a life.
Damn.
Forced roll.
Taking risks.
6 points.
Let's go again. Hit me.
Yes. 22. 16, you're at 22. Yeah, I think it's a good idea to take your points, especially since you're at 0. Okay, round 4, it's 2 forced rolls. You get a 9 and you lose a life. And 2 forced rolls in this round. Okay, you got 19 for the round. Do you want to keep playing or do you want to take them?
Take them.
All right, 2 forced rolls. 8 points on the first, 7 on the second.
Take them.
Okay, round 7, we're at 3 forced rolls. Probably get screwed, but we'll see. And yeah, you got 56 points. So,
Cash out.
to go a little bit into this code and how it's organized, I declare a module main because it's an executable. It's got to be in a module called main. I import data.char, system.io, system.random, which are modules that I'm going to use. And then, here we go through the process of declaring a constant, very exciting, and declaring a function. And I got a lot of questions about 1/3 rounding up, or about quat in particular, like what is quat? Exactly. It is integer division. So, if you divide 100 by 7 as a float, you get another float. But sometimes you want to say, ignoring remainder, what's 100 divided by 7, and that's 14. There's also div, and I think the difference is how it handles negatives. I think that one of them rounds towards 0, and one, like div rounds lowest, and quat rounds towards 0. And then you have rem and mod, which are analogous. So, yeah. And then, we have roll d6, which is an action. IO means, for now, just think of it as an action and think of the type parameter as what it returns. So roll d6 is an action that returns an int. And I'll go over the exercises at the end of the class. Most of the stuff is, for example, interpreting a roll, where we look at the pair of dice and then we say, okay, what happened? Was it snake eyes? Was it a doubles? Most of that's purely functional. We don't have to do IO to do it, which is what we want. And generally you want to keep your functions small. As you can see, this is kind of a monster play around. This is sort of the main workhorse where we say, okay, based on the the round number. We take 1/3 of that, rounding up. If the roll number is greater than that, we ask. Otherwise, it's a forced roll. And then we roll the dice and print out what you rolled. And, you know, that's a fair, by Haskell standards, that's a big function. And probably I could stand to factor it some. And this is play game. And the one important thing I want to show is that main, which is almost always of type IO unit. Unit is a type that carries no information. Main is what actually gets executed. So that's just a brief run through of the code. What else is there to go over? One pattern that came up is the looping pattern, where you have some computation that is looping or recursive. Haskell doesn't, I won't say we don't have a for loop. You can create one. It's just not very idiomatic. We generally use recursion. And you'll often see us saying, okay, play around, round num. Well, what are the things that change throughout each iteration of playing around? Because a round is an iteration of dice rolls. Well, the score changes, and the number of rolls that we've done changes. So those are the two loop parameters. We define a loop function that will either end, then we break out of the loop, or we call loop again. A simpler example of this would be, if you wanted to do, this is now a GHCI. This is the tail recursive factorial, because there's nothing stopping you from doing that. But what you'll often see is the tail recursive version, where you have a loop, then an accumulator, if this works at HCI. Right, the accumulator starts at 1, and then one hopes we get the same result. So what we see at the bottom is the tail recursive factorial, where we create a function called loop. Has an accumulator value called 1, an accumulator value that starts at 1, that's called ACK, and then the n. And as n counts down, you're multiplying n by the accumulator. And what that gives you is, if you look at the main body, which is this if-then-else statement, you're either returning the accumulator, which is at the end of the loop, or you're making another call to loop. And because you're ending with a function call to the same function, rather than having, as in this case, this external context around the recursive call, you can throw away the external context, because everything you need to know is in the parameters.
So does loop only take can you pass an arbitrary number of variables to retain to the loop function, or can you only
Of course. I mean, the loop function is something you define internally to the function that you're writing, and it can have as many arguments as you want. I just wanted to show that pattern because you're going to see a lot of it.
So wait, what was happening when so if n equals 0, then ACK. So what happens with ACK right there?
Okay, so the accumulator is it's a parameter. It's being threaded in. It starts at 1. So you start with loop 1. Start with loop 1.5, loop 1n, and then it says, okay, well, 5 is not equal to 0, so I'm in this else clause.
Oh, so it's just checking, okay.
You've gotten to the end of returns.
23. And it just goes to, when it terminates, it's at loop 120, 0, and then it says, okay, I hit 0, so I'm done, so I'm going to return the 120.
Okay, and you, okay.
So,
I feel like
It's-
some parentheses would help with the understanding.
sure.
Not that that's like how you should write.
Actually, that's something I'm going to discuss because you've probably seen a $ symbol, which is actually part of the reason why it's there is to remove parentheses.
Yeah.
Um,
When learning things like that, or like learning a functional language, usually like adding parentheses to help grasp.
absolutely.
is helpful.
Absolutely. And I personally don't think Lisp is that hard to read. I think people who complain about the syntax are just whiners who need to, just shut the fuck up and learn. All right. So I'll demo a couple things. I already stepped through lab1.hs and ran it. I'm just going to go through compiling Hello World, the ways acted with GHC at command line, just to show you that it can be done. Usually with a Cabal project, you're not going to be running GHC manually. But all you have to do Hello World is open your text editor. As you can see, I already have it in there. It's IO of unit, put Sterlin, hello world, and GHC hello world. Actually, I think I have no idea what the difference is with adding make in this case, but the way I've always seen it done is with dash make. And now you have an executable, and you run that executable, and it prints out hello world. Can everyone see that? Let me actually move this up so you guys don't have to struggle to see it. So that's all there is to making an executable. Cabal will set up your projects for you. There are a lot of complaints about Cabal, which are well-founded, and it's being worked on. There's also a build tool called Stack that I haven't looked at yet. But
What was the function you used?
I'm sorry?
What was the function?
Oh, put Sterlin. I'll actually wait. It just takes a string and spits it to the console.
Seems a little verbose for that.
Yeah. Well, it puts this string, so it's put string, and then lin is print a new line.
Oh, I see.
Yeah,
I
it's
was
like
thinking
print
it was
line.
like referencing string length or something. I don't know why.
Oh no, no.
I see.
It feels like Java.
No, it doesn't.
Well, Java, it's like system.out.println. Like, I mean, to write Java, you have like, it's almost like a fucking APL keyboard where you have like the public static void key and the system.out.println key on your keyboard.
Macros.
I'm stuck right now.
How to link different libraries? You just import the modules.
I'm sorry?
How do you link different libraries?
Uh,
How do you export? Like I have something I want to, but I don't want people to see the code because it's messy or it's a secret. But I want to, create a library for the people to use. How do I?
okay.
The module?
I'm sorry?
Is that like a module?
So there absolutely is. I don't know offhand exactly how it's done. I work with Cabal pretty much exclusively. And, but I will say this, executables are generally statically linked. So you can always ship a binary without the source code, if that's what you're looking for. And I guess I'd imagine that libraries, you can do the same thing. GHC and Haskell are the product of people who understand the Unix and C way of doing things. And
So you can't include a binary into other Haskell code, can you? Because it's going to destroy like all of the actual code. Like I can't ship a binary and then include it as a module code. Could you?
ship a binary.
Like you can import a binary. Yeah, that's my. So like it
think-
could only be used for the actual like execution of that code that's there. You couldn't use it to like.
You probably can, because Haskell has something I'll get to later in the course, the foreign function interface, which is how you call C code.
Yeah.
I also know that there's a way to call Haskell code from C. I have not used that particular bit of functionality, but I know it exists. I'm gonna move along because so yeah, I demoed GHC, but this is just a slide that reminds a reminder slide. So you've probably noticed that the code looks different in source code from how it looks in the interactive mode. In the interactive mode, you preface everything with let, and in the in source code, you often don't. And it's kind of like this. On the left, you have let 6 equals 6, and on the right, you have 6 equals 6. And the type hints that I have in the source file, file.hs, usually you don't have to include those. There are exceptions when it can't resolve an ambiguity, but in general, you don't have to give the type hints, but it's really good practice because ultimately your code is going to be read by humans.
It's also easier to debug when like it's trying to like create this type system for you. And
Exactly.
It blows up all over the place.
Exactly, and it can also make your compile times faster, I believe, because
Doesn't have to
ultimately,
interpret it as much.
well, yeah, type inference is solving a system of equations based on all of the context that it sees around all the different variables. And if you give type hints, then you're solving some of those equations ahead of time. So there are many good reasons to include type hints on every top level function of the program. But you don't have to type your inner functions, which is nice. So the other usage of let, which is local assignment, retains its original meaning. So you can use let in compiled code. You just don't want to use it. You don't want to use let for declaration in compiled code. That's a GHCI specific thing. But this guy, where we're declaring giga to be kilo to the third, where kilo is 1024, that's fine. That has the same meaning. There's also a where clause, which is like let in, but it allows you to have your sub-expressions after the main expression. So up here, this is a neuron in an artificial neural network. We're saying that when we fire it, we are computing g of bias plus weights dot inputs. And then if someone wants to look up what g is, which is the logistic transfer function, or what dot is, which is the dot product of quarks, they look down below. In general, you should prefer spacing for blocks and have each entity of a block be on one line rather than separating with a semicolon. So as you can see, this guy on the left, that is one GHC line, and it works. And it's exactly the same thing semantically as the guy on the right, but the one on the right is readable, and the one on the left is a giant headache. And I will point out now that Haskell does have semantically meaningful white space, so your indentation has to be consistent. Now, as long as you're consistent, you're fine. So in do blocks and case of blocks and all the other blocks that you're going to see, as long as your indentation is consistent, you're good. So this works, but so does this. It's non-conventional. We have 3 spaces for the first level and 6 for the second. I don't know why anyone would use that, but the compiler is going to be able to figure it out. And this also works. Like if you're really trying to keep things from going off to the right and you're only indenting 1 space, again, as long as you're consistent, you're okay. But this guy would not compile. Now, I don't think this is as bad as it seems. When I first heard that Haskell had meaningful white space, I was like, what kind of horrible decision is that? But it actually enforces good style, and it's not really that hard to get right.
So is that, do you have to be consistent throughout your entire file, or just the definition of a specific function? Or like in a specific semantically relevant?
The latter. The latter. The reason The reason it rejects something like that is because if you have nested case of blocks, then the way that you communicate which lines correspond to which block is through indentation. As long as you're consistent within a function, you're probably going to be fine. As I said, let in retains its original meaning. You can also have let blocks where you essentially, this is really 3 let ins, but you're just writing let and in once. X equal 15, y equals 30, z equals 37, prints out 37. And as you can see at the bottom right, as you can see at the bottom right, run GHC with a file name is another way to run the main method, sort of like a script, essentially. So let's investigate this I/O thing that has continually popped up in the source code and will continue to pop up. We're going to handle it more formally later. We'll define what it actually is. It's, as you've probably heard, a monad, and we'll get to monads around lecture 5, lecture 6. For now, it's a parameterized type, and an IOA is a stateful action that returns something of type A. And if it doesn't have a meaningful return type, that is, it's an action that's just being used for side effects, then it's IO of unit. Unit type only has one value.
What do you mean parameterized? What does that mean?
Okay, so remember how I showed lists, how you have with this is how the list that Haskell actually has is defined, except it has different syntax. That list of A is parameterized. So for every A, there's a type called list of A. So you have built-in list. And parameterized means that it's a generic. It can exist for any type A.
So something that happens in Rust, which is why I read some context, is that Rust will build out. So say you have for generics that Rust has, what it actually does is it actually builds it out for every type that exists that utilizes that. It's not like a true generic in terms of like what the polymorphic sense. Like it's actually just syntactically generic that ends up expanding out into all types that utilize it. So when you do that in Haskell, is it like, it's not, I would very doubt it is, but it's not like prematurely built. We see parameterized in it that it exists, like list A exists for all types of A. What you really mean is that any type A can have a list A.
Exactly.
And that eventually it would. It doesn't do that beforehand.
Right, it's not going to generate every single list type for every type because the space of types is infinite because
Well, you can use the space of relevant existing types. Like,
fair enough. Fair
yeah.
enough.
Just making sure it's figuring out that.
So parameterized type is essentially something that, so a list of A is either empty or it contains A's.
No.
An IO of A is a stateful action that will return something of type A. That means that there isn't one IO type. There are IO types for every type that exists. So there's an IO int type, which is the type of IO actions, stateful actions that return int. So here are some example I/O functions. We have getChar, which gets a character from the console that has type I/O char. And then putChar is a function that takes a char, and when you give it that char, it returns an action, I/O unit, that will print that character to the console. And it doesn't really have anything to say other than I did it, so it returns a unit. getLine gets a whole string from the console, basically reading characters until it gets a new line, and then putStirLin takes a string, puts it to the console, and then puts a new line to the console. And finally, I have fileExists down here, which is a function that takes a string. That's the file name. And to know if that file exists, it has to make a system call. It has to ask the operating system, does this file exist? And that's doing I/O. So it's going to return a Boolean value based on whether the file exists at that time. It's not actually doing anything. It's just polling. But because it's dependent on the state of the system, it has the I/O type signature.
Or whatever native exists to tell you if a file exists could also delete your operating system.
I'm sorry?
Like whatever native extension for determining file existence, like whatever, you could have made that as like the environment could make that delete the operating system or something. So
That would be terrifying. But
my
yes.
point is that's why that's an I/O.
Why do getChar and getLine not take a print? Why do they not take a type? So like is console input just like nothingness? Is it, so that's just saying it returns an I/O char?
Okay, so getChar can be read as a value of type character, except it's dependent on system state. So for example, if I am over here, it's going to depend on some kind of outside signal, mainly me doing something, and then it's going to say, okay, that's an 8. So
that's not defined as taking a type?
no, it has a type, but it's not defined as a function.
Okay.
Although, interestingly enough, one way to think about I/O is I/O of A is a function that takes a world, where world is the state of the whole world, which you can't actually formalize inside of a computer because it's too big. And it returns an A and another world, where that world may have been changed. So you can think of getChar as world arrow world, wherein what it does is it getChar takes whatever the current world is, and it returns A and world with one less, with I'm hand waving here. And that actually is the semantically correct way to think of I/O, is it's a function that takes a world, returns whatever that type parameter is, and then it returns an updated world where things may have changed.
Provided the entire universe is an argument to one of the functions.
Exactly. So, and this takes a while to get, and I will be repeating these concepts because they're not easy. They took me a long time when I first approached this language. I was looking at it, I was like, because in a language like OCaml, which is another functional language, something like getChar is explicitly a function that takes a unit and returns a char. That's an OCaml. And here, the char is an I/O of char, and it's like, well, that's not a function, so isn't that just the same thing? Well, no, because it's dependent on the outside world. That's also why fileExists has to return an I/O of bool, is it's not even about the fact that checking your file system could blow the world up. It's just the fact that it's dependent on outside state. So next thing, I'm actually writing lecture 6, which focuses on monads right now. So I'm actually coming back to this later and giving it a more formal an exact treatment, but there's do notation, which you're going to see a lot when people deal with I/O. It's actually more general than I/O. It works for anything that's a monad, and I'll explain what a monad is in the future. But for now, just don't worry about that and just worry about I/O. You put I/O lines together, and each of those I/O lines can have one of three forms. The first is letting a variable equal an expression. That's stateless. It doesn't do any I/O itself. It's just a way of saying, okay, I want this variable bound to this expression. The second thing you can do is that you can use the reverse arrow to put the return of an expression of type IOA into a variable. That variable is going to have type A, and it's something that would be used later on in the do block. And you'll see examples because it's hard to explain without showing it. And then finally, you can just have a barren expression of type IOA. And the last IO line has to be of the third form, because the only reason you would bind a variable to an expression is to use it in a later form, and so it doesn't make sense to bind it to something that would just be thrown away.
Wasn't that because IO inherently returns an IO of the type that you're working with? Like, that's the arrangement?
That as well, yeah. The IO action will always return something with an IO. And one of the reasons why monads are such a good way of representing state is that they are, what's the word I'm trying to, they're contagious in a way. So once you have an IO computation, any function that uses that computation will also have an IO in its signature, and that's enforced at the type level. Unless you do this thing called unsafe perform IO, which is bad, or usually bad.
The state gets passed through each IO call.
Anything that calls like the IO,
Yeah.
we'll have to deal with that. It has to bring into its type signature.
And I think I'm going to show that actually in a later slide.
Is that how it, like, you notice with like error handling in languages that are similar to this, where you use monads everywhere? Is it basically like you write a bunch of code and then you get down to one little piece of code that's like being utilized, by something, and you're like, well, shit, this returns, this returns a result, right? Or I'm not sure what the coinage or the term for it would be, but it returns either an error or what I wanted.
Sure.
And then you realize, like, okay, so now I realize, okay, so my last function needs to take an error and this, and then all the way up until you get back to your main, which I probably throws that away or does something intelligent with it. But is that how you do error handling in Haskell as well? Like, do you basically return results?
So the short answer, and I'm going to have to accelerate a little bit because we're running low on time.
Feel free to bypass that. If it's addressed in a later class, I'm happy to.
It is. The answer on error handling in Haskell is it's complicated. Some legacy issues because pure code should it does an IO of it's an IO that returns how many files are in that directory. And thanks. What I intend to show is that these IO these IO lines don't have to have the same type. So we're doing account files, that's IO int. We bind that to C, get an int. Then we're doing a stateless computation where we let many, which is a bool, be true if C is greater than 100. And then we're returning this string that says, say 79 files. And if you have a lot of files, then it also says wow. And the type of the whole block is IO string, because that's the last thing that's returned. All of these other intermediate values are not part of the return, so they don't show up in the type signature.
What did you say the dollar sign did again?
Oh, the dollar sign. that's just function application. The reason it's there is because of the left associativity of function application. If you don't have it there, then return will consume show C, and then it will consume plus plus, which is another function, but return only takes one argument. And so you get a type error. So I'll explain the
So
dollar
that kind
sign.
of allows you to condense everything into one thing that you're returning.
Yeah,
Okay.
So you don't have to put parentheses around the whole thing so that it evaluates that whole thing first.
exactly.
And then it's returned. Sweet.
Exactly. So here's a do notation example that's much simpler. We get a char, we bind it to C, and then we put char it. That's called echo char. Not much to that guy. In English, it's exactly what I said. And the type of the combined IO is the type of the last action, and put char it doesn't really have anything to say other than I'm done. So the type is IO of unit. Now, return, which you've seen a lot, it's not a special statement. In fact, it's just an ordinary function. And in the IO monad, return X is the no op. So when I say IO A does IO and returns an A, what I really mean is it might do IO and it returns an A. Because return X gives you the one that doesn't really do anything, it just returns that value. So for example, when we roll two d6s, we do a roll d6, that's an IO int, bind that to x1. We do another one, a different one, bind that to x2. And then the process of returning that to, the process of returning that is not stateful. Rolling the dice was stateful, but now we have these values. We put them together in a list and we return it. And the return takes that list events back up into IO of list events and gives us the type signature that we need.
So the x1 and x2 in that case are not IO of it.
They're just
They're
in.
just in.
Yep.
Because that.
Yep, exactly. Let is a stateless assignment. We've seen that, but just another example. This is an incrementing echo. It does a get char. It uses ord, which you have to import data.char to have access to convert that character to an integer, to the code point. It adds 1 to it, uses char to put it back into to make it a character again, and then it put chars it.
I'm trying to figure out, so C in that case,
Monad.
so that you can work with it with your other IO shit.
Exactly.
Okay, so it's specifically in this context that get char with that arrow in a do block returns just the actual raw value.
Exactly.
So that's like calling a function and assigning it to a variable.
The-
Is that what in this context?
Yeah, it's allowing you to say, okay, so get char is an action, not a very interesting action. You build actions out of more actions. And this guy up here is an action that gets a char. And then the question is, what does it do with that char? Well, that char, C, it calculates ord of C, which is stateless, which is why it's a let line. That's an int. And then it does put char, which is another action on the character corresponding to that code point. Did that make sense? Maybe it's a little...
So out in the wild here, just if you look at out in the wild, outside of a do block with that arrow pointing back to an assignment or to something it can assign to, the type of it is returning an IO char. But because we're in a do block working with it, then it's just a char.
Let me show something that might make it easier. This is something I was planning on holding off till later, but I'll just show it. So what's actually happening is there's a function called bind, which has that symbol. And for any monad, and ignore the type class, just assume that we're working in IO. So replace the M's with IOs. What that will do is it takes one action of IOA and a function that takes a pure A and returns an IOB, and then it returns an IOB. And to give an example of what that looks like, when we take get char, we want to work with that char somehow. And we can't do that in pure code, but we can do that with bind. And bind takes a C, and this C has type A, which in this case is char. And let's say, that we're doing the exact same thing. Although I'm going to have to and I've got to import data list. So get char is IO char. This C is char, but it's this whole function right here is a function of type char to IO unit. And so the result of the bind is an action. It's a compound action. So, wait. See, and it increments the character. So the way that you compose these monadic actions, the fundamental composition is binding, which is where you say, okay, I have this action on the left. I know it returns an A. And I want to bind it to this function that tells me what to do with that A. And the way it specifies what to do with that A is as a function that takes an A and returns an action that returns a B, or that has type signature A arrow IOB. I can go over this offline. This is hard stuff. This took me a lot of time, and in fact, I'm going to keep coming back to it because it's difficult. But once you get it, the beauty of it is that you can reason about state and what is happening statefully. So, and I want to point out that the let form is actually identical to the reverse arrow assignment if you use return to lift that A into the IO type. So you don't really need, the let form is just a nice add-on, but you don't really need it. This is the sequencing operator. This is a cousin of the bind that I showed you. I'm pointing it out because I used it in the lab 1 code. It essentially says do A1 and then do A2 and return A2's result. So you're still doing A1, you get all the side effects, but whatever A1 returns is just thrown away. Another thing that I have to explain is show, which is our toString function. It's got this type signature, a show A constraint. That means that it's not for all A, it's only for A's that fulfill the show type class. I will go into type classes in depth in lectures 5 and 6 because they're a necessary prerequisite for understanding all this monad stuff, because monad is a type class. But show says if you have an A in the show class, then it's A arrow string. Int, by the way, is show, so we're good there. Concatenation with ++, that's another thing that we used a lot in the code that concatenates 2 lists, and since strings are just lists of characters, we can also use it on strings.
It's the only place in the code where you have comma is in the list in Haskell.
Comma. Well, you also have tuples.
Tuples. Okay.
Yeah, you also have tuples. And you also have the comma operator, which creates a pair.
Yeah.
So I'll go over that at some point if you want. Finally, there's this error function. Exceptions in Haskell are kind of a mess because when you have laziness, you don't know where your exceptions are necessarily coming from, and it can be painful to debug. And really, the reigning ideology is that pure code should not throw an error unless it's a hard crash. A hard crash meaning that, okay, this program just can't progress at all. But you do see this function error, and it can return in any type A, but it doesn't return anything. And those two things actually mean the same thing, because failure, which would either be a hard crash or a non-terminating computation, is assigned this value called bot, which is this upside down T that happens to live in every type A. And in fact, it's the only thing that lives in every type A. Another bot example is this infinite loop. It recursively calls itself over and over. The compiler doesn't have enough context to figure out a type because it never returns, and there's no value other than it defined in terms of itself. So it gives it the type signature for all TT, which means that the compiler is actually detecting that the program never returns anything successfully. So that's kind of cool. Okay, so onto the exercises. How much time do we have? What are we at? 7?
7, almost even.
Okay, great. So we can talk about these. Why is rolling a die stateful? Why did it have the type signature IO event?
Since it's a random.
Okay.
Kills the global random.
Yes, it uses the global random number generator. Randomness is never referentially transparent because it relies on some kind of state. In particular, we're using random RIO, which uses the system state. So what's another conceivable type signature that you could have for rolling a 6-sided die? Anyone have any ideas?
Could just return an int and then be loaded.
You mean like the XKCD comic?
Yeah.
4?
4. It's a random number achieved by rolling a 20-sided die.
Okay, but let's try to do a little better than that.
Okay.
An object representing the first structure representing the dice.
Sort of. I mean, an object is really a glorified closure, and a closure is a function. So what I have, and I'm maybe hand-waving a little because I don't define RNG state, but you could replace your implicit state that you're getting out of I/O with this explicit threaded state, where you say, roll d6 is a function that takes an RNG state, it returns an int, and the updated RNG state, which kind of is analogous to what I was doing where I was saying that IO of A is world arrow A comma world. And then rolling 3 dice would look like this. You know, it's a function that takes your initial state, you roll d6, get a roll and state 1, roll d6 using that state 1, get R2 and state 2, and so on. And then what you return is the list of the roll results and the final state.
So since the compiler would technically have at least something different, like some piece of different state every time it compiles, and the compiler also knows about its own state, then you could technically do randomness-ish without ever having to use external state.
I don't think the compiler itself does anything with the randomness.
I mean, it could just include what time you started the command and then you go.
Yeah,
I would
but
just say, like, you could potentially not have an IO action because all the state that you need could be enclosed and known about.
so you're having the compiler, you're having non-deterministic compilation, which is a terrible idea.
I'm just saying.
No, I mean, yes, that could be done, but why?
I don't know.
So you could factor that previous thing to be like monadic, passing the state through and using
It is
do.
monadic, yeah.
So,
Yep.
well, but you could use do notation to do that.
You could, because do notation works on all monads, and I'll get to that in lecture 6. I have a fair amount to cover, but yes, you can use do notation with any monad. You'd have to declare that as an instance of the type class monad, but it could be done. So what do head and map do? Anyone not know the answer to these? So yeah, they're list operations. Head takes the head of the list, and map is that guy that we've seen that applies F to every element in the list. So head looks like this, and it actually fails on the empty list. It's not give it the empty list, and it doesn't know what to do. So we call that partial. That's generally considered bad style. So if Haskell were designed now, probably head would be like safe's head may, which returns a maybe. Map is probably the most important function. At least it's how I introduce functional programming. So we all know what it does. How might we write it? Like if map didn't exist, how would you write it?
You could use head and tail, like pattern matching on an array, and then recursively apply a function to an element. And then I'm trying to think of how you would like retain. Well, you could have it as
You'd like build the accumulator and thread it through.
That's one way to do it. You can define, there's a function I'll get to later, fold. Actually, there are various folds, which is a reduce, and you can represent map as a fold. That's not quite what I'm going for, but that could be done. And your suggestion is problematic because head fails on the empty list, and we want this map function to work on the empty list.
You so add the case.
Right. So map f empty list is going to be what?
When well, I guess we're talking about the original one. You would always return a result from a map. Anything that's operating on arrays almost always should return a result of some type. Which
Right.
would be either, or I don't know if you wouldn't call it, not necessarily a result, but a meaning type. So you would have none or an array of type, whatever the array is.
I guess you could make an intermediate function that recursively calls itself with, like map would call that intermediate function with the full list and empty list. And recursively, that function would take one item, put it into and call itself with the.
That's identical to the fold suggestion,
Okay.
and yes, it works. There's a more elegant way of doing it, which is this guy. So map, if the list is empty, it doesn't even look at the function. It just says, well, the image of that under F is obviously the empty list. And if it's x cons x's, then it applies F to the x, and it does a map of x across the x's, which is the tail. So you guys were collectively, if you take the sum of what you were saying, correct. It's an inductive definition. That is not tail recursive, but that actually doesn't matter in this particular case because lists are lazy. But that's something I'll get to in, I think lecture 4 is where I really drive into laziness.
Well, the only piece of the stack that remains that the only piece of the stack that you ever have in that anyway is the accumulator, which is essentially the argument to the next map. And so, like, not the argument, but it's the, like, it's not tail recursive, but if you did it tail recursively, you would have the same amount of state left over.
Right, right. I think that's correct. I need to think about that. The other thing to keep in mind is that these lists can be very large, even infinite. And we want our map to, what this is essentially saying is, if we have a cons, which we can figure that out in finite time without evaluating the whole list, then we know we want a cons, and if we need the first element, it's there, and the tail is just the map of F applied to the tail. So exercise 4, where I had this line in a do block, rather than binding a variable to something that to an IO action, I'm binding round result, points scored, lives lost. What am I doing there? Like, what language concept am I using?
You're
Is that the last line in the do block?
It's not. It can't be because the last line has to. It can't bind any new variables, and this is binding points scored and lives lost.
but it's not really like a true monadic bind because it doesn't return it wrapped in. It's like
Oh, it's-
unwrapping.
It's binding as in binding a value to a variable, which
Yeah.
is totally different from the monadic bind function.
So it's just giving play around round number returns an IO, whatever, an IO tuple, and then you've got that guy right there, which is like pattern matching against the
Bingo.
return of the IO tuple.
Bingo, it's pattern matching. So how might that fail?
If that doesn't match the pattern,
Right, and why is that not an issue in our particular case?
because we have static typing. We know what that's. Oh, well, we don't really. Well, yeah, we do.
Well,
But the IO thing,
it's not.
whatever it generates, it would fail at its own point.
This one actually requires looking at the code.
Is it because round number is always greater than 0?
No, it's because
You think that could never fail?
in this particular case, because this guy only has one constructor. So everything that is in the round result type is going to match the round result pattern. Now, if we had something like foo bar equals foo of int or bar of string, and then we did foo x arrow some expression that returns a foo bar, then we couldn't do that. I mean, then if it was built with the foo constructor, it would be fine, and if it was built with the bar constructor, it would fail. But because round result only has one constructor, we can do that.
There's only.
Would that even compile?
Yes, it would. It would compile. Sure.
That's returning a struct with two fields, right?
It's not a function, so it's not returning. But yes, round result is a struct with two fields.
So what about that pattern shows three, it's like finding three elements that are tuples. What's the third one?
No, it's binding two.
Oh,
Point
I see.
scored
Round
is-
result. with
Yeah.
the two. Sorry. I was thinking
Yep.
it was like, it's,
Under the hood, there are three things because under the hood, it stores the constructor tag, I think as an integer. So under the hood, this would be like, this would be some integer that just is used to match and say, okay, it's a round result.
it's not a tuple. Because like I was thinking that was tuple pattern matching against that. It's just in
No.
parentheses to say that you get a round result with these two fields.
But tuple pattern matching is exactly the same thing where, you know, if you can always do, that's going to bind X and Y.
So the lack of the commas is what should have clued me in that it wasn't.
Right.
Pattern matching on the tuple.
Right. And tuple pattern matching is completely type safe because you always, because each tuple type only has one constructor. Like the pair,
Generic.
well, no, not because it's generic, but because it's defined as this guy. It's not like foobar where there are two different constructors. This is how pair is defined. And it's yelling at me because, but yeah, like that's how the pair is defined. Because there's only one constructor, it's type safe. Or it's runtime safe. You're never going to have a pattern match failure. So there are the answers to that. Pattern matching, when it fails in the IO monad, it's a hard crash. Okay, so exercise 5 was something that I was just hoping people would do to get comfortable writing some code, hacking some code. Not really much writing, but you know, it says you lost 1 lives. That's a shortcoming of the code that I've written. And the way that you would change this is to add this plural function. You give it an int. This is one way you could do it. You know, because you want to factor your plural stuff out into its own function rather than corrupting an already big main method. It's not the main method, but it's one of those big monster functions. You factor out plural and singular like so, and then you just replace it. And finally, you know, I said, you know, to define factorial like so. That definition of factorial is completely correct. There's nothing wrong with that. But when you type in factorial, factorial 3, you get a type error. So first of all, why is that a type error?
Because you're trying to pass 2 arguments to the first function.
You're on the right track. I mean, you're not incorrect, but that's not the most correct answer. What is the first thing that it tries to do when it sees this expression? No. I think, Zach, did you say it?
What?
Oh, so when it sees factorial, factorial 3, is that going to go to factorial of 6 or not? No.
It's expecting its first argument to be of type n.
Exactly. It parses it as factorial, and that's a type error.
What the dollar sign.
Exactly. That's why the dollar sign is so there are 2 ways of fixing it. One with parentheses, one using the dollar sign. I just want to review 2 things. I've actually covered these in previous classes, but it's good to go over them because they come up over and over, and they can be annoying. Associativity and the infix operators. So as I've said before, there's no distinction between operators, which are defined in symbols and usually infix, like plus, and the functions, which are usually words and usually prefix. You add parens around an infix, and voila, it's a prefix, as we see with the plus. And you add backticks around a prefix function, and you can now use it infix. You can define your own infix operators. So here I have, you know, plus and angle brackets as the sum of the absolute values, and you can now use it infix. In fact, that's going to be the default way to use it when it's defined that way. Any 2-argument function that you've created can be used in infix notation with the backticks. So here's something that I've created, add an inverse square, and I'm using it in infix, and it works. Yeah, what's up?
So, could you have like a 20 argument function that you can use as an infix that returns the like curried version for the rest of your usage? So out of curiosity.
I believe it would work. I believe it would do. I mean, keeping in mind the left associativity, I believe it would do what you think it would do. Let's actually try that out because I'm curious now. I'm just going to do a 3-argument function. Let f x y z equal x plus y times z, and then I do 5 f 6 7, and it does not work.
Because it's going to apply 7. Try to apply 7 to 6.
Yep, there we go. Dollar sign saves our ass again.
I would probably be angry at anybody who did that, though.
Yeah.
So does the dollar sign evaluate everything to the right of it?
I'll get into the dollar sign.
Doesn't it just start the left associativity there? And then
Yeah, I'll get into that. So as we recall, function application is left associative, as we've seen over and over, and that's why we get our type error. Factorial is int arrow int, so factorial is ill-typed, and the compiler tells us to fix it, which is what we want it to do. If there are any questions about whether left associativity includes multi-arity, the answer is it absolutely does because of the currying. F123 is just quantity F1, quantity of that applied to 2, and then the whole thing applied to 3. And you can see the types of each intermediate form at the bottom. And this is what it looks like in lambda calculus. If you want to review that, if infix, or not infix, if left associativity and currying are giving you trouble, just review this until it makes sense and come to me if it never does, and it will. And so the 2 fixes are, the one up top is with the parens around factorial 3. We get the part on the right to happen first, we're good, or we can use the $sign, which now I have to explain because it has this really boring looking type signature. It looks like it's just function application. It's just another 3 characters or another 1 character at least that doesn't need to be there. But it does have a use because of order of operations, or what we call precedence. So using the :info compiler directive, you can see where something is in the order of operations. And higher number means it's tighter, and lower number means it's looser. So $sign is very loose. A $sign goes right to the bottom of the parse tree. Infix R means that the $sign is right associative, unlike function application. So if you see A $sign, B $sign C, you get the B $sign C calculated first. That's a good way to make your computation associate from the right, which is often what you want. So precedence class 0 means that $sign is lower than pretty much anything else, just as your plus is going to be lower than your asterisk. Now, you can look up the infix, what they call fixities of all these operations. Plus I think is a 6, or times is a 7, but really, unless it's obvious, you should just use parens. But with $sign, people become used to that, and it's kind of a special case. You can always assume that people know the $sign is lower. As we see on the bottom, we have f.g. Dot is function composition, $sign x plus y. That is intuitively clear to a Haskeller that f.g is happening and x plus y is happening, and then they're coming together. But when it comes to fixity, unless it's obvious, just use parentheses. Infix operators that don't have a declared fixity are going to be left associative, and they're going to have level 9, which means that they bind almost as tight as prefix functions, which bind the tightest. So if you see this form out there, where plus star $sign is just something that I've created, we see the parsing, and the parentheses are colored so you can match them. And as you can see, the function applications are the tightest thing, and then the plus star $sign is less tight, and then the $sign is a little less tight, and then the plus is the loosest. And if we had a $sign, then that would be even looser. And in general, it's idiomatic to use $sign rather than parentheses. So either one of these works, and sometimes you do want to use the parentheses. And honestly, I don't think parentheses are the worst thing in the world. I mean, I've written closure for enough years to be used to it. But when you can, it's generally better to use $sign. And so now I'm done for the night. I hope this lab has been instructive and informative, and I'm open for questions, assuming that my wife isn't pinging me. Okay, we're good. Anything? You look very pensive, like
I
you're.
just wanted to make sure that if I had any questions, going back.
Sure. So how do you guys feel in terms of like readiness to read and write professional code? I mean, do you feel, 40, 50% of the way there?
I mean, I definitely feel fine.
Good. good. I mean, my goal is that so just to sketch out like what's remaining, 3 and 4 are list operations and laziness. 5 is type classes. 6 is getting to monad and why it works the way it does. And then there's going to be another lab, which is going to be based on the parser for this Lisp interpreter that I've written. The interpreter itself will probably be lab 3. Then I'm going away for a week at the end of July. And my goal is that by the time I leave for vacation, that people will feel professionally ready, like that they're ready to, crank out some Haskell code. And then we can get to fun stuff like lenses, Haskell on the web, high performance Haskell. Now, a lot of that stuff is going to require research on my part because, I mean, this stuff I pretty much have down, but, lenses are an area where I'm still learning. I use them in my lab 2 code. So if you want to look at that, the only thing about that piece of code is that the macro system is completely broken. I tried to do something clever where I had macros being an entity in the language, and it doesn't seem to be working. It has a scoping problem. But anyway,
Word.
so
Thanks.
all right, thank you. Okay. Wonder if there are any questions from California since I turned off my hip chat. All right. Close this thing out.